In this first section of 6.5, we are going to take a look at the equations of parallel lines and the relationship that exists between them. So you guys probably looked at parallel lines when you were in middle school, and you know that parallel lines are, by definition, two lines that never intersect. So over here on the graph, you will see a set of parallel lines. The red line and the blue line are parallel to one another. And if you look here in the wording of the problem, I have provided you with the equations to the two lines. So here is the equation of one of the lines, and here is the equation of the other. Hopefully, what you notice about these two is that they share the same slope. That relationship is going to be true of any pair of parallel lines. So parallel lines always have the same slope. So always for parallel lines, same slope, different y-intercepts. If their y-intercepts were the same, they would be the exact same line. So same slope is really what we need to know. So on this first example here, are the graphs of these two lines. So if I graph these two, would they be parallel lines? We should be able to figure that out without actually creating the graph at all. So the first equation that you see here, which is y equals negative 1/3 x plus 5, that is already written in slope-intercept form. So because that's already in slope-intercept form, I know that the slope is the coefficient on x. So this line has a slope equal to negative 1/3. But if I look at this second equation over here, 2x plus 6y equals 12. That equation is written in standard form. And from standard form, we do not know the slope of the line. So I can't say at this point if they're parallel. But if I change this second equation into slope-intercept form, meaning that when I get done with it, I want it to be in y equals mx plus b form, I should be able to know if the two lines are or are not parallel. And remember, if I want slope-intercept form, basically I'm saying that I want to get y by itself. So to do that, I'm going to start by subtracting 2x. This is the same thing that we did a few days ago. So these cancel out, which means that I can say that 6y is equal to negative 2x plus 12. And then if I want to get y by itself, I'm going to divide each term of the equation by 6. So these 6's cancel out, leaving me with just y, and that's equal to negative 2 over positive 6. That doesn't divide, but that does reduce to negative 1/3 x plus 2. So the slope of this equation, the one that we just wrote into slope-intercept form, would be negative 1/3, which means that the slope of this second equation is the same as the slope of the first equation, which allows us to say that these lines are parallel. And again, we were able to tell that without having to create the graph. Moving on to the next example. In this example, we are going to be working to do the same thing. We're trying to determine if I graph these two, would they be parallel lines? So in this case, the first equation, the equation that you have here, is written in standard form. So from standard form, I do not know the slope. So I'm going to work to rewrite this into slope-intercept form, which again means I want to get y by itself. So I'm first going to add 6 on both sides of the equation, 6x. So these cancel out, which means I can say that 8y is equal to 6x minus 24. And then I need to divide every single term in the equation by 8. So the 8's on the right-hand side will cancel. So I have y equals 6 over 8 reduces to 3/4. So 3/4 x, and 24 divided by 8 is 3. So 3/4 x minus 3. So in this case, all I care about in determining if they're parallel is whether or not they have the same slope. So the slope is 3/4. So if I move to the second equation over here, this equation is already written in slope-intercept form, which means that I can look at the equation, and from its current form, I already know what the slope is, which is 3/4. So since these two lines have the same slope, that means that the lines are parallel. In addition to being able to tell if two lines are parallel by looking at their equations, we also need to be able to write the equation of a line that's parallel to another. So in this example, it says that we are being asked to write an equation for the line that contains the point 5, 1, so that means goes through the point 5, 1, and is parallel to y equals 3/5 x minus 4. So remember, if two lines are parallel, that means that they have the same slope. So for the line that we are given, the slope, this is in slope-intercept form, so the slope is the coefficient attached to x. So if this line has a slope of 3/5, then a line that's parallel to it will also have a slope of 3/5. So I know that our line has a slope of 3/5. I also know that it goes through this point that we see over here, which means that I have enough information to write my equation in point slope form. So point slope form, again, looks like this. So this ordered pair over here would be my x1, y1, and my slope I already know. So if I fill in the information, I will have y minus 1 equals 3/5 times the quantity x minus 5. If I want to go ahead and rewrite that into slope-intercept form, I would need to first distribute the 3/5. So I would have y minus 1 equals 3/5 x minus 3. And then to get y by itself, I would add 1 on both sides of the equation. So these would cancel out, and I find out that y equals 3/5 x minus 2. So this equation, the line that I just described by the equation y equals 3/5 x minus 2, would be parallel to this equation we had in the beginning. So if we look at one more example like that, on this equation here, it says write an equation for the line that contains the point, so goes through the point 2, -6, and is parallel to y equals 3x plus 9. So again, if we are parallel to this line, we would have the same slope, and the slope of this line is the coefficient on x. So that line has a slope of 3, and our line that we write the equation of will have a slope of 3. We also know that our line goes through this point over here. So we have the correct information again for point slope form, where this point would be your x1, y1. So point slope form, y minus y1 equals slope times the quantity x minus x1. So we would have y minus a -6 would become +6 equals slope, which is 3 times x minus 2. So to get that into slope-intercept form, we would need to distribute. So y plus 6 equals 3x minus 6. And then to get y by itself, we will subtract 6 from both sides. These cancel out. And I find out that y equals 3x minus 12. So this line here would be parallel to this one that we started with.